For anybody who didn't hear me talk yesterday, I'll whip through who I am real quick again. My name's Bill Sempf. You can find me on Twitter. Personally, husband, father. Normally my family travels with me, but they didn't make this trip for some reason. I'm an author. I've written for Rox and Wiley. When Wiley bought Rox, 2006 timeframe or so, they took over the imprint for Rox. But I actually moved to the Dummy series, the yellow and black books, kind of appropriate, if you ask me. I consider myself a software composer. It's kind of an unusual term. I picked it up from this book called Lorem Ipsum. Lorem Ipsum is a 136-page kids book about software engineering and computer science. And frankly, I learned more in that 136-page book than I have in, I did in 8 years of college. In the book, Lauren walks through this fantastic world where there's all the boroughs are kind of made up of software development practices. Thank you very much. I appreciate it. For instance, there's the brute forcers that pile rocks on top of rocks to build their edifices. And then when they crumble under their own weight, they put more rocks on top to make another one. And one of the groups is the composers, and the composers live in this fantastic world with these beautiful spires and lofty buildings. And what the composers do is they make beautiful things out of beautiful things. And that's very much how I think of myself in the software world. I haven't twiddled bits since I was like 9. We don't work directly with the computer anymore. We work with modules and other pieces to put things together. And the more creatively you put things together, the more beautiful things you can make. So that's how I view myself in the software development space. This tells a little bit older deck. If anybody's seen this intro before, this is the slides changed. I've spent the past 3 or 4 years doing software application vulnerability analysis. Generally speaking, I have a funny set of slides where it says application vulnerability analyst and it falls off the side of the slide because that's quite a mouthful. A lot of people use the term auditor to define it from, differentiate it from pen tester, which I am not. So pen testers are given a job, well, this is a security crowd, you know this. Pen testers are given a job to do, and then they can accomplish it however necessary. Steal my Etsy password file, go. All right, well, I can pick the lock of the server room, I can sweet talk the secretary, I can find a vulnerable web application or server to get into. Application vulnerability analysts or auditors take one application, so our scope is very narrow, but we have to find every flaw. And then we write a report. So, in a way, our job is slightly harder than a pen tester's, but we're less likely to go to jail by accident. So, I think the trade-off is real. On the personal side, I'm a home brewer, a lockpicker, and if you haven't been up and played with Adrian's stuff in Lockpick Village, please do so. He brought everything with him. I am a ninja, not a security ninja or a programming ninja, actually like 5th Cube, Anshin-Shukai Ninjutsu ninja. And I'm something of an insurrectionist in the development space. I have a habit of opening my mouth when it's when it's going to have the most good, but nobody really wanted me to. One of those things. In the security space, that's not so much. Security people are kind of used to doing that, so it's one of those things. So we're going to talk about security and REST APIs today, but to start off with, I want to give you a gentle introduction to REST. How many people are familiar with REST as a concept? Okay, most of the room. Good. Well, we'll start with something. We'll start with something gentle here. So REST is nothing more than a fancy term derived out of what is underpinning all of the World Wide Web. Okay, so your browser is a REST client. It is using the underpinnings of HTTP to move data from a server to a client. All right, that's all it is. It is HTTP, browser communications, redefined for API development. Okay? So the verbs of HTTP, which have been around forever, since they first, when did they start writing the RFC, right, in 88?
Sorry folks, I'm Geek here. We had a video freeze up, and we didn't notice it until about, 11 minutes and 40 seconds in. So if you want some audio, fast forward to about there, and audio should resume. Sorry for the problems.
all the great server headers and software headers that tell us what's going on under the covers, right? What else? Exception management, right? Errors happen in REST APIs just like they happen in regular web pages. If you do not properly handle your exceptions, then you are going to run into trouble. So REST API should use the HTTP status codes to return errors to the client. Very similar to how SOAP services should return fault objects, fault envelopes, and a regular web page should send you to redirect you to an error page and log everything. All right. So there are processes in place to handle this. The response codes are the REST API's version of how we communicate back to the consumer of the API what's actually going on. And then, of course, in the exception message itself, you leave as little information as possible. So how about authentication? So authentication is a real problem, and we'll talk about it again, actually, at the end from the design perspective. So how is authentication done here? Oh, never mind. I've got a tag that says it. So what are we doing here? We are passing a secret in the URL. But that's okay, because we're under TLS, right? It's under TLS, so it's secure. Ever heard that from your developers? Oh, yeah, sorry. Yeah. So there's our API key, right? So we might have some people in the room that don't know. You cannot leave a password in a URL. Even under TLS, yes, the post parameters are encrypted in TLS. I'm sorry, the post parameters. The query string parameters are encrypted in TLS, but they are still logged everywhere. They are logged in the browser. They are logged potentially in bookmarks, less so with REST APIs. They are logged in the web server and potentially cached in routers. We do not leave secrets in URLs ever. Okay? So how do we solve it? Well, a real good choice is OAuth. And we're going to talk about design at the end when we talk about architectural considerations. But OAuth is a great way for two services to communicate, right? But it's not so great of a way for a client and a service to communicate. That's not what OAuth is designed for, okay? When you need a client and server to communicate, you want to look at HMAC. So HMAC is hashed message authentication code. And it's a process where the client and the server both know a public key and a secret key, okay? So the public key is the client ID, right? It's whoever you are. So what you can do is you take all of your parameters, including your public identifier, your public key, your client ID, whatever, and the date and time. Attach your secret key to it and hash it. Then you take the secret key out, put the hash on, and send it to the server. The server takes the hash off, puts the secret key on, hashes it, and sees if the hashes match. If we do, we have all kinds of benefits. We have authentication, because the client name's been passed. We have non-repudiation, because we know that it has been tampered with on the way. And we protect from timing attacks, because we have the time the request was sent. So it's a remarkable solution to the problem. But passing your password, clear text, in a query string is a bad idea, even under TLS. So session management. This is why we don't implement our own session management. This is the things you need to do. Don't bother reading it. It's up there like that for a reason. When you were developing a REST API, you do not need session management. It's amazing how many REST APIs I test that still have some concept of session. The fact is, the machine does not mind authenticating every single time. Okay? If the user's authenticated to the client, like an Android app, okay, that client does not care if it has to re-authenticate with the server every single request. Now, the user would care if they had to type in their password every time, but they don't. They're authenticated to the client. The client says, I know who's using me, so I am going to re-authenticate using the credentials that I know to the server every single time using HMAC. Every request is HMAC authenticated. The server doesn't care. The client doesn't care. The user doesn't know. So the way you avoid session management problems with REST APIs is to avoid session management. So injection, information disclosure, authentication, session management, all things we run into in regular web applications, all things that are just as apt to REST APIs frankly, we could list probably 90% of the rest of the things you test for when you test web applications, and they would still apply to REST APIs. They need to be tested like the rest of the web. REST, however, could also be attacked in special ways. You have secrets to manage, for instance. Cross-site request forgery is still a consideration, but we have a special piece of that. I realize that's a normal web attack, but there's a special take on that. Unused HTTP verbs, because we're opening verbs we've never used before. Most websites only use get and post. Direct object reference considerations, and the famous mass assignment vulnerability. So let's start with management of secrets. So, obviously this is a secret key. You should treat it like a secret. Putting it in the URL does not treat it like a secret. But see, we've got all these problems. REST is usually called from JavaScript. We have all these fantastic JavaScript frameworks out there. So if I've authenticated with the JavaScript client, then the JavaScript client needs to authenticate with the REST API. The only way it can do that, if we're going to remain pure to our beautiful backbone.js platform, is if the JavaScript knows the secret. But see, there's this little itty-bitty problem with that. The JavaScript has been downloaded in plain text to the user. Okay? So what are we going to do? Well, I hate to tell you this, and this is going to be one of those times when being the security jerk is going to come across to your development staff. We simply do not have a way currently to have a pure JavaScript client. It's not possible. There is no way you can hide an API key in a JavaScript client that I can't get it. It's going to require a server-side call. No matter what, it's going to require one. After the user authenticates, a session will have to be established, and the key, the secret, will have to be derived from that session. And that is it. There is no way around it right now. Now, that could change tomorrow. Somebody could make a change to the browsers, whatever. But today, your architecture astronaut who's going to write this pure Angular app for V3 of your website, it's going to at least have one server call, and that's to get the secret key. End game here is just, lock up your stuff, right? You got to lock up your stuff. There's no way to keep that key client side and not have the user be able to steal it. So cross-site request forgery, you all know what it is. I don't need to tell you. Basically, I mean, it's a relatively sophisticated attack designed to steal cookies using the wondrous nature of browser tabs, largely, and a little bit of phishing. Of course, the benefit to the way we've developed our REST API based on the previous section, right, is that we don't got no cookies. If you're working this properly, okay, there shouldn't be session management for the API. Yes, the user might have a session, and that might be stealable from the Angular application. That's still possible. However, the REST API itself is going to authenticate every single time. Okay? Using that nonce that we discovered. So, no cookies, no cross-site request forgery. They may be able to forge the session in the app, but they're never going to be able to forge the session with the API because there's no concept of the session for that. All we've got is that nonce. Once the nonce expires, then they're out anyway. Unused HTTP verbs. This is a lot of fun. So the vast majority, honestly, everyone I've seen, REST API uses 4 verbs, right? Get for select, put for insert, post for update, and delete for delete, right? 4 verbs that are in the HTTP standard and constrains, I mean, it puts that natural constraint on the REST API, what makes these APIs so beautiful to work in most of the time. The problem is that there are a lot of verbs. And with most web servers, when you go in and say, hey, by the way, I need more than just get and post, they turn on all of them. IIS is the worst, and at best, and unless I missed something, it's still true in 8.5. If you go in and there is literally a switch to turn on the other verbs, and it turns on all the verbs, and the only way you can turn off the couple of verbs, you turn on the couple of verbs you need and turn off all the rest, is to make a metabase change. It's crazy. Apache's the same way. But Apache's easier because everything's text, so you can go in and fiddle with it. There are some really unique attacks from this. You can bypass authentication by using session fixation, right? By passing a head request in and getting a pre-authenticated session ID for applications that are vulnerable to that. So you need to learn for your platform how to turn on only the requests you need and none other. And it's going to be different for everyone. This is .NET, right? So direct object reference is one of my favorites. So often APIs are in play because they were used internally for SOA apps. Everybody remember in the early 2000s when it was like, oh, we're going to service all the things. So we took all of our DCOM and Corba apps and we wrapped them in a SOAP wrapper so that all our front-end applications were now speaking services instead of digitally binary connecting to closed source, black box communication. Well, 2005 iPhone comes out. Boss man comes down from the top floor and says, hey, I want an iPhone app. It's like, I don't know how to, what do you want it to do? Same stuff our website does. Well, we'll have to, recode all the logic into iPhone. No, don't do that. Just take our API and poke it through the firewall. It'll be fine. It isn't fine because the web server is in the DMZ, right? So you control that. Well, hopefully. You control that. Hopefully you're the only one that controls that. So if you have things like object referenced by an integer, for instance, you know that you don't have to worry about somebody iterating that integer because you have the web server in between those two things, and hopefully you're not also using that integer out on the public web, but some of you probably are. Hopefully you are not, but the API, it's okay, right? If we're going to use the ID, the integer ID to refer to something, it's fine because it's controlled by the web server. So let's talk about Facebook. Facebook has an API. I don't know whether you know that. It's called the Open Graph. The Open Graph is actually, if you haven't looked into it, you should if you're a Facebook user, which security crowd, I know probably only about a third of you are. The Open Graph is what app developers use to access the information of people who've installed or approved access to their app. Okay, so if you install my app, I actually have API access to all your posts, all your friends, probably all your friends' posts, and anything else that I may have asked for that you would have given me. So it's a really great marketing tool. That's how Farmville, whatever the company does, Farmville, that's how they're making their money. Not by ads or anything. It's by selling all that data that they're collecting from all the people playing Farmville. The base unit in the Open Graph is a user. That makes sense. Is the prime object in Facebook, because that is what the prime object in Facebook is a person. So if you call the base of the Open Graph, right, in version 1, the ID you use to reference a user is just a big int. It's just a number. So for instance, if you go make this call right now, you will get Mary Louisa. Good old Mary, right? And this is all the information you get from Mary because Mary's profile is not very public as it should be. But, of course, only about 60 to 30% of Facebook users have any privacy controls at all on their profile, but I chose one to show you that does have the privacy controls on. So what would any good hacker do presented with a situation like this? Change the number. Get the next guy. Chase. 11 lines of Python later, I had 400,000 Facebook users. So that's a direct object reference, insecure direct object reference. Facebook does not think it's a vulnerability. It's been turned in 50 times to their bug bounty program. They're like, dude, this is how it's supposed to work. We're like, you don't think this is a problem? I mean, do you think Chase and Mary would be upset if they knew that I downloaded even that much information? Probably. I mean, maybe not, but probably. Considering most people, I got all their posts from their page and everything. So, I don't know. It does get worse than that, too. I mean, obviously, you probably heard about the Chase hack last year where somebody was using the investment system and then realized their account number was in the URL, so they iterated it by one and got somebody else's account. I mean, who does that? Anyway, so it's not unique to API to REST, but it's surprisingly common in APIs compared to public web pages. I mean, the Chase thing was an unusual case. That was just a web app. It was just a Tomcat application, right? That's a normal web application. But APIs are particularly susceptible to direct object reference vulnerabilities. So the mass assignment vulnerability is a unique and interesting attack that is unique to Active Record, which is a common ORM used underpinnings of REST APIs. It became very popular in Ruby on Rails, especially. And basically, where it stems from is developers basically trusting anybody, right? So we have a person object and we want to map it back to our database. The Open Record will do that automatically for us, basically, right? So if I want to create a new person, all I do is I say, hey, here's my form, and all the fields on the form are named the same as the fields in my database. Active Record will automatically map it and just make the new person for us. Understand? Just real straightforward. As it turns out, though, if I pass in a flag, or pass in a field that isn't in my form, so it isn't published, but I know it's there. Say, for instance, they're using a common person object that's been in a bunch of books, which almost everybody does, and I know that field is there. I can set values in there that aren't actually in the form object, but that since I know about it, I can just change it anyway. Because Active Record is trying to be helpful, right? Developers want to be helpful. They want to be nice to people. So even if it's not in my form, I can just pass the value into the API and it'll make the change for me. It's generally known as failing open and is one of the 7 mortal sins. It wasn't just Ruby either. ASP.NET, Java, and PHP Active Record scenarios all fell victim to this vulnerability. Pretty much, fixing it is easy though. Pretty much all you need to do is make sure you build your class smartly. Unfortunately, the classes are often auto-generated, so it becomes a bit of a problem. You've got to work within the constraints of your own framework to fix the problem, but that's one of those things. Additionally, you have the issue of having to break the positive security model and blacklist fields you don't want available for your forms, especially in ASP.NET. I'm not a big fan of that. So there's 5 ways that REST can be attacked in special ways. Let's talk for a few minutes about how REST has special architectural considerations. So HP did a version of this talk, basically, a big review of REST security. I was very surprised to see that they really only focused on infrastructure type things, largely. I see a lot more to it than that, but maybe that's just me. Architecturally, so before you begin building your API, probably too late for most of you, but I'm sure there'll be more APIs in your future. Before you begin, there are 4 things you need to consider very carefully. We've already talked a little bit about authentication. How to protect your keys, and how to convince your users of your API to protect them for you. How to view your URL, because perception of that is going to increase the overall simplicity of your API, and in general make it more, and because you're increasing the simplicity, you're going to increase its security, right? Because complexity is the enemy of security in API development. And finally, treating your API like a website in many ways. So first we're going to carefully consider our authentication, right? So somebody at Google said it's okay to pass the secret key in the URL because it's under TLS, right? That's what something happened. So that isn't good enough. Starting out with HMAC is your best bet. And then handling well, I'll talk about that when I get the keys. Starting with HMAC is your best bet. Almost all REST implementations in platforms already support HMAC out of the box. You do not have to build your own, but if you have to, you can. It's not like you're building your own encryption. Just remember to use the baked-in hashing protocol and make sure you do it properly. All right? However, if you can, consider if you're service to service, using client certificates instead. All right, so if you're communicating between companies, for instance, with APIs, validating both servers with TLS is a fantastic solution for authentication. and it requires very little in the developer's line. Because one of the main reasons why HMAC isn't more heavily implemented is because it's relatively difficult to code for. But client certificates takes it kind of out of the developer's hands. They don't have to worry about it nearly as much. So treat your API keys with PKI rules. I don't have any good slides with this, and I really should make some. But this comes back to, in JavaScript, there being no good way to keep your key secret. So every authentication scheme that's between the user and the client is going to have to then receive a nonce, a session-specific nonce from the server, so that they can use that to be the secret for communicating between the client and the API. Okay, I mentioned it before. I'll say it again. For JavaScript applications, for Android applications, iPhone, Windows Phone, whatever, there isn't a good way to hide that. If you use client certificates on the client side of a phone app, you have the potential to use the certificate store in the phone, and I've seen that done, but it's relatively difficult to implement for the user, right? Because the user is going to have to go through the process of making a public-private key pair in order to use your app, and that's just not going to fly most of the time. So you're going to end up making that call back to the server to get that nonce one way or the other. The key is, though, is to make sure that anybody who consumes your API, you either force them to protect their key by only providing them with HMAC and nothing else, or you heavily suggest they protect their key and make it very clear in documentation and in contracts related to use, EULAs and whatnot, that key needs to be protected, because that is basically a private key. I mean, the key to the API, that's the first tier that gives the attacker a way in. So we need to make sure we protect that. So treating the URL like a method signature is really a design point. This is something that your software architects should be doing, and if they're not, then they need to be educated. Part of the problem I showed you with that first slide with the map of that API that's like an eye test. Part of the problems with REST APIs is that when the architect initially envisions it, it's this beautiful, simple, straightforward model of the business, and then the business analysts get to it, and it's like, oh, actually, this has got to have this in it, and this has got to have this in it. We're going to tie all these together, and you forgot about this form people fill out. It's got 955 fields in it, and how are we going to model that? And so if you remember that this is this, and they're literally the same thing, modeling the API will continue. It's like that Zen moment, right? We'll continue to maintain the simplicity of the API. Even the Rastafarian model, if you're sticking with pure inline parameters, like the original paper states, doesn't matter. It's still just a method signature. And if we continue to view it that way, then it'll make the system simpler overall. And by the way, I don't know if you know this, but we talk about Rastafarian stuff. Burp actually has a switch that you can throw so that you treat inline, what would normally be treated as folders in a website can be treated as parameters for testing REST APIs, just for the pen testers out there. So treating your API like a website, right? We've gone over this already. We've already set that premise that a REST API is only different because of the output. It's the only thing that's different about it. It's sending back JSON instead of sending back HTML. The bad guys use their already very well vetted tools to attack the REST APIs. Everything they use today, Burp and Metasploit and all the other tools, work against your API. It just requires a little bit of extra setup and maybe making a client, okay, in SOAP UI or even in their programming language of choice in order to really exercise your API. They're going to use the existing tools against you. So you must get a pen test. You must use secure coding practices. Yes, I know. I'm sorry. I've got to use this picture every single deck. I've got to. I can't. I mean, you all know we don't do that, right? That shit is hot. That's the kicker. Yeah. I believe, is Jason in here? No. Yeah, it might be, very well be. Yeah, I got to use it in every deck. I mean, it's literally, and it's funny because all my decks, I've been converting them over time into trainings. So when I do full day or half day trainings, I basically use a version of this deck in my training. It's a module. Crushed down to about 40 minutes, so you have time for an exercise at the end, stuff like that. But if you sit through like 2 days of my training, you see this picture like 9 times because it's in all the original text. Anyway, so you must get a pen test. You must use secure coding practices, the same ones used for your website, and you must use static analysis, just like what Wolfgang said before. And I don't remember the guy who spoke after me yesterday, what he said. Those tools apply to your REST APIs just like they do to your website. So there you go, 4 pieces. So where does that leave us? Just a couple other things. The reason I use the Google API for all of this talk is because they support the bug bounty program. And if your application doesn't, you might want to consider it. It's not only does it open the security research community up significantly and give us a platform to work on, to teach, and to learn and work on in conferences like this, and like my OWASP group, once every other month we get together and do bug bounties as a group. BugCrowd has an awesome like intermediary project where smaller companies can go. If you don't want to run your own bug bounty program, you can go through BugCrowd and they'll manage it for you. It's a pretty neat system. Or making one of your own like Google does is a pretty awesome thing. Anyway, that's all I've got for you today. I'm not going to run through a ton of conclusions because I think we concluded each section pretty well. But I'm at Sempf on Twitter. If anybody has any questions, I'll take them now, or I'll be hanging out for a little while, and you can hit me with stuff. But I'll take anything you've got now. If anybody has anything, Bueller. All right, I'll let you go to lunch. Thank you very much.